Alright, tonight's video should also be short, sweet, and to the point. I have here the box from the top of Tuesday's quiz that tells you everything on the quiz. First, one-dimensional kinematics problem solvings. So that means just solving for x or just solving for y, some unknown variable. So v naught, acceleration, position, something, and just in one direction. Then free fall, so something that's only moving in y, only having to keep track of y. There's two of those equations. Kinematics graphs, which is from the last quiz. Vector components, and projectile motion. So let me just say, you need to be able to basically do everything on the last quiz, and the stuff I'm talking about tonight is a refresher. It's not a complete everything that could possibly be there. I'll do just like I did last time, and at the end of the video talk real fast about what's on the quiz, just kind of scroll through it and tell you my thoughts on what you need to know. But anyway, I have a few things we should definitely review. Here we go. Alright, first off, remember this slide from about 3 days ago in class. You should be able to answer all of these questions about the vectors over at the right. Now we did this in class, so I suggest pausing the video, trying to answer all the questions about the vectors. In fact, go ahead and pause the video, and I'm just going to write the correct answers on the screen. So you want to pause it so you can try to get the correct answers, and then you'll see the correct answers in just a second. So here are my answers underlined in green: largest magnitude B, positive x component E and D, negative y component B, D, F, non-zero y component B, C, D, E, F, 0 x component B. If you got any of those wrong, try to figure out why. Call me, call a friend. Get it right. Alright, moving on to the next slide. If you need to pause and make any notes, go for it. Alright, you should be able to do this problem, and more specifically, you should know why the answer to this problem is correct. Remember, on this one, the only thing that matters for how long the cars take to fall is their height. And that's always true in projectile motion. The only thing that matters for how long something falls is its height. So if you're comparing how long it'll take something to fall compared to something else, look to its height. So why don't you try this problem, rank the times that the trucks take to fall from longest to shortest, pause the video. When you come back, I'll give you the right answer. Alright, here's my answer. B and C are tied with the greatest height. D, G, and H tied next with the second greatest height. A, E, and F with the shortest height, and therefore the shortest time. And notice I indicated ties with an equal sign. That lets whoever grades this know that I think that the ones with equal sign are equal. Okay, so in projectile motion, when you're comparing the fall times of things, all that matters is their heights. Height is what determines how long something takes to fall. Alright, if you need to pause or make any notes, do so now. Biggest thing to remember, height determines how long it takes something to fall. And height alone. Moving on. Okay, I'm scrolling through the quiz. I've got one question that asks you to solve for an unknown using one of the top 3 equations on the blue sheet. I've got a couple conceptual questions about free fall, and then a couple math questions about free fall. There is how to use kinematics graphs, so finding displacement from a velocity time graph. If you're given a position time graph, how to make a velocity graph. If you're given a velocity graph, how to make an acceleration graph. Facts about vectors, and not just facts about vectors, but actually using vectors. And then a projectile motion question, and your free response. I have not decided yet, but will most likely also be a projectile motion question, so be ready for that. Okay, that is all. Have a good night, and good luck on the quiz.